Hello and welcome. My name is Deborah Choudhury, and I'm going to talk about for our final project, which is a line follower robot using PID algorithm. And as you can see, the robot is moving along the track using a PID algorithm. So to start off with, for our project, I've created a new world at first, and then after that, after creating the new world, I have added a texture background, a factory, which is a factory, and then I've added a background light. I've given a background light, and then after that I've added a rectangular arena uh, for this rectangular you know rectangular border consisting of four walls and a floor. I've given a light color except a black color, because since we have used infrared sensors, so we could not use a color, a black color, so we had to use any other color other than black. And then since we were asked to create a robot and could not use a pre-built robot from the Webot, created a robot. So in the robot part, um, in the children part, I've created the body shape, and the body shape is of box, and I've added the color, the red color to it as well. I've used four wheels, and the wheels are denoted as hinge joints in the Webot section on the left hand side. The four hinge joints, so the two on the right and two on the left. And in the hinge joint part, in the device part, I've used a rotational motor, and I've given wheel one. And this name should be same to the code part as well, which will be explained later by my groupmate Fahim. So apart from just connecting the four wheels, I've used three distance sensors and also transform. So transform is used for so that our robot could move, and distance sensor is used at first when we were just making this road project. We wanted to see if we could implement a code and make the robot move right, left, and forward. But since we were asked to follow a line, and to follow a line, you need a sensor. And since we were using an infrared sensor, we had to use that sensor. But since Vbot doesn't have an inbuilt infrared sensor, we had to change that distance sensor into infrared sensor, and I've done it in this option. Inside the distance sensor option, I've changed from my type, so it was generic. So if when we just need to do any general distance sensor work, we don't need to do anything. But since were doing this infrared sensors, we were being the logic of infrared sensor to our robot, so to our sensors, so we had to change that type to infrared. And apart from it, well, I have named the distance sensor as DS mid, DS right, and DS left. So this mid, right, and left are very trivial things. So like mid means it will go just forward. Right and left means whenever it will get a right path or a left path, it will go accordingly. It will just turn accordingly, and it will not come outside this line. It will follow this black line. And since it follows the black line, we had to you know uh, position the ray in such a way that the ray is towards the ground. And I will show it. So since the ray needs to be towards the ground, as you can see, there are three rays moving along the black track. The three the three rays are all together. So this tree needs to be towards the ground, since we are making the robot move along the track. So this was how I built the line follower robot, and the rest of the part, like the code and the simulation part, will be explained further by my groupmate Fahim. Thank you.
Assalamu alaikum. My name is Sheikh Zaman and my ID is 18101 I will be discussing the simulation part and the coding part of our line follower robot. So let's first run the simulation and see what's happening. Here we can see the robot is running and it's following the line. So let's just stop this and let's see how we have made the track. So we have went down to Tinkercad, and from here we have created a new project. So from here we will select Scribble and place it right here. After that, I have made, we can draw the track that we want to make, any kind of track that we want to make. I have made my track something like this. After that, just press the done button, and here we will select the height to be as much as less as possible, and selecting a color from here, we will select black, and we will export it in an OBJ file. I have already done that. So after that, we have downloaded the file. We will find an file name tinker.obj. So we need to import it. So for doing that, we will go to the file, then we will go to the import 3D model, From here, we will select the path that the object is in, and we will just select that object and done. After that, we will see that there is a section named Tinker or Obj. So here we will go and we will select the scale, and we will just make sure the track is with this environment as nearly much as possible, so that our robot can align perfectly with the track and the environment. So after that, uh, how is the robot actually detecting the track? So for this, we need to have a basic understanding of how the IR sensor works. So let's go there. The IR sensor has an emitter and a detector. So the light is emitted and it is reflected back with the detector. And whether when the detector is detecting the light, we can say that the IR sensor is perfectly working. We will get a value out of this. So this is how the IR sensor actually works. So in this robot, we are actually running our robot on a white plane and track with a black border. So this black border will have a different value and this white part will have a different value. So we have implemented that in our code. So let's jump into the coding part. Here we have imported the robot. We have a time step counter. We are having the sensors here. And here we are just implementing the motors. And there is this main part where the robot is actually running from. We are having an infinite loop here. So there, after we are going to a for loop inside it, and here we can see that we have selected a threshold value. So how can we exactly get the threshold value? For this, we need to have a trial and error situation here, because we need to run this robot here in the white plane and then go to this black part, so that we can differentiate what the value of the black part is giving us and the white part is giving us, because every color has a different value. So here we are using some if else statement, so that the value is not less than 500 and it's actually within the 1000 range. So if it's within the 1000 range, the robot is following the black line from here. And if it's not in here, we can use the PID algorithm that we have learned in our theory course. So we are implementing the PID error here. If this value is getting an error, if it's not within our range, we're having a function named the PID, from where we are adjusting the value and returning the value. And with that value, that rectified value, we are adjusting the speed of our motor to run the robot on the track. So thank you. This was from my part.